यस, देखिए इससे पहले वीडियो में हमने आपको रियल फंक्शंस के टाइप में बताया था और लास्ट हमारी डेफिनेशन थी एब्सोल्यूट वैल्यू फंक्शन यानी कि मॉडुलस फंक्शन। इसके बाद नेक्स्ट डेफिनेशन हमारी आती है सिग्नम फंक्शन। तो द फंक्शन f is defined by fx is equal to mod of x by x, where mod of x जो शो करता है एब्सोल्यूट वैल्यू फंक्शन को और that is equal to 0 when x is equal to 0 or when x not equal to 0 then this. That is, if you see here, mod of x by x is equal to 1 come if x is positive. If x is positive, then that is say x if x is greater than 0. So therefore mod of x by x should be equal to 1, or if x is less than 0 or if x is less than 0, so then mod of x is equal to minus x, or this is equal to say minus 1. Or when x is equal to 0, then it is 0. Is called a signum function if the domain of the function is all real number. And here we can take the value of the x is any real number, and the range of the function is only the exact three numbers minus 1, 0 and 1. The graph of the function is shown in the figure as you see. देखिए here यहाँ पर हमने x is equal to 1 is not include. X is equal to there are x is equal to 1 to infinity आपका, और यहाँ पर आपका x is equal to minus 1 to up to infinity, but x is equal to 0 is not included because at x is equal to 0 the function is not defined. So therefore we can take the value of the function at x is equal to 0 should be equal to 0. Here जो 0 है, this point is denote the break point. At x is equal to 0, the signum function is denoted by the sign of fx. Yes, देखिए नेक्स्ट डेफिनेशन है ग्रेटेस्ट इंटीजर फंक्शन, और ये डेफिनेशन हमारी मैथमेटिक्स में एक बहुत ही अहम डेफिनेशन है, तो इसको हमारे लिए डिटेल में जो है अंडरस्टैंड करना जरूरी है। देखिए द फंक्शन f इज डिफाइंड फॉर एवरी x बिलोंग टू R, दैट इट मींस फॉर ऑल रियल नंबर fx इज डिनोटेड बाय ग्रेटेस्ट इंटीजर, दैट इज स्क्वायर ब्रैकेट डिनोट द ग्रेटेस्ट इंटीजर्स लेस देन और इक्वल टू x। ये जो डिनोट करेगा that is equal to x. If x is an integer, then greatest integer x should be equal to x, or if x is not an integer, then the greatest integer x is equal to that integer which is immediately to the left of the x. For an example, here we discuss. Suppose if we take that it is real number line or 0, 1, 2, 3, or that is say 4, minus 1, minus 2, minus 3, minus 4 and so on. देखिए यहाँ हम सब एग्जाम्पल्स लेते हैं। अगर हम लोग देखें 5, since 5 is belong to an integer, 5 is an integer, तो therefore the as per definition the value of 5 should be equal to 5, यानी कि अगर हमारे पास में ये कोई भी इंटीजर है, if the value 5.9, अगर हम लोग यहाँ पर ले 4 इसके बाद 5.9, तो the left integer of the 5.9 is equal to this, because it is not an integer, so therefore we take just immediately first left integer of the 5.9 is 5. But minus 5 is also an integer, but it is a complete integer, therefore minus 5. But here minus 5.1, अगर हम देखें तो यहाँ पर जो है माइनस के 5.1 हमारे पास में ये आ गया, दैट इज से माइनस के 5.1। तो ये जो हमारे पास आएगा माइनस के 5.1 की जो वैल्यू होगी, दिस इज द लेफ्ट इंटीजर -5 और 0.1 ये, तो दिस शुड बी इज इक्वल टू आपका ये जाएगा माइनस के 6 और माइनस के 9.2, माइनस 9.2 मीन्स दैट इज से माइनस के 4.5 और this should be equal to -5. If we see here some more examples, -√3 or √2 and so on. So minus the value of the -√3 is equal to the value of the √3 is equal to आपकी जाएगी है माइनस के 2 के इक्वल। The value of -√3 should be equal to minus के 2 because similarly if we take the value of the -5 means 22.7। अगर हम लोग देखें यहाँ पर 22.7 और -√3 आपका 1.732 और माइनस का, तो द लेफ्ट इंटीजर ऑफ -1.732 इज दिस, हियर ये है ना। तो therefore the value of the -√3 should be equal to this is, or this is equal to minus के 2, just left integer. Similarly if we take the value of the pi is minus के 22.7 or this is equal to -3 point something and so on, so therefore the left integer of that is also is minus के 4. So therefore we define the greatest integer function. If x is integer, then we take the value of this is equal to the same integer. But if x is not belong to the integer, in this case we take the value of the greatest integer function is the immediately left integer. Yes, देखिए for greatest integer function there are some facts. The value of the greatest integer function should be equal to x in case of x is belong to the I, and the value of the greatest integer function is the left integer immediately if x not belong to I, or the value of the greatest integer function should be equal to k if k belong to I. यानी कि that is the for example if we take the value of the x, suppose हमने 10 लिया, so then the value is 10, or if the value of x is the value x is like, if the value of x is like here k plus 1 or up to k, अगर वैल्यू हमारी x की लाई करेगी किसके बीच में, if this value is lie between k and k plus 1, that is also equal. So in this case the value of the x is lie between k and k plus 1 where k is an integer, or if k belong to I then x plus k, or that is x or plus k. For an example if we take that is 2.3 or plus 5, हम इसको निकालना चाहेंगे तो we can write that is 2.3 plus 5 और 2.3 का left integer that is 2 plus 5 और that is equal to 7. या हम इसे डायरेक्ट भी ले सकते तो that is this, or also we can write that is 5 or to 7.3 or this is also equal to 7. Now we draw the graph of the greatest integer function. देखिए the graph of the greatest integer function is also a very interesting graph. कैसे? No, in the graph of the function देखिए we take the value of the x is lie between 0 to 1. So therefore we can take here x is lie between 0 to 1. Here the left integer is included while the right integer does not include. So by the fact number this third, the value of the greatest integer function should be equal to the value of the greatest integer function is equal to 0. Similarly, this is equal to 1 if the value of the x is lie between 1 and 2 and 1 is included, left integer will be included and 2 and this and so same. So therefore first of all we find the table for the some values of the x and draw its graph. देखिए if x is include, ये यहाँ पर इसको include करेगा और every real number between 0 से लेकर के और आपका 1 तक. तो in this case the value of the y should be equal to 0 if the value of x is lie between 1 and 2. Here 1 is included, so then the value of the y should be equal to 1. Height of the graph is 1 and that is also same is 2. Similarly we see here the depth of the graph is -1 and -2 and so on. So therefore we get the graph of the greatest integer function just like a sphere. Yes, one more definition, fractional part function. The function f is defined by fx is equal to x minus greatest integer function is called a fractional part function. Since greatest integer function is defined for all x belong to R, that is since the domain of the function is R, greatest integer should be equal to k if k belong to I and the value of the variable lie between k and k plus 1. For example, that is. So therefore, by taking the value of the k is -2, -1 and 0, 1, 2 and so on, then we get, if we take here k is equal to 0, अगर हमने k is equal to 0 लिया, तो then the x lie between 0 to 1. Understand? जो हमने टेबल तैयार की है, by taking is this, here k is equal to 0 and here that is 1. So therefore x lie between this and we get by the definition of the greatest integer function, the value should be equal to x, or that is say x minus 1 or that is say x minus 2. By putting here, अगर हमने यहाँ रखा x और इसकी वैल्यू होगी हमारे पास में 0, तो then we get it x और यहाँ पर आ गया हमारे पास में x minus 1, x की वैल्यू लाई करती है 1, तो that is say 1 or the left integer 1 or it is for an example if we take x all real number and that is 1.9, so this is equal to x minus 1 and as well as is x minus 2 and so on. For an example, if we take the graph when x is lie between 0 to 1, then we get y is equal to fx, or x by taking x is equal to 0, we get this is 0, or if we take x is equal to 0.5, then we get y should be 0.5 and so on. So therefore the graph of the function in this interval, that is a straight line with inclined at an angle is 45 degree, that is 45 degree, that is 45 degree and so on. So therefore that is x plus 1 and so on, parallel line. So therefore the graph of this function is this and its range is lie between 0 included or up to 1. From the graph, if we read the range of the function which is lie between 0 include but 1 is not include. This function is called fractional part of the function. Yes. operation on the real function. Operations on the real function means जैसे addition, subtraction, multiplication and division of the two or more than function. Let we consider f and g are the two functions which are defined from a set x to the set of real number where the set x is also a subset of R. Then first of all, the sum of the two functions f and g are denoted and defined as f plus gx is equal to fx plus gx. For an example, if we find the function fx is equal to suppose 2x square, or that is gx is supposed say a sin x function, so then f plus g we get a new function, or that it should be equal to separately fx or plus k gx, or this is equal to 2x square or by plus k, that is say sin x. So therefore the addition of the two different function f and g is equal to this. Similarly, if we want to find the difference of the two function f minus g is denoted by in place of plus we get the minus, and fx minus that is say gx we calculate. Similarly, if we define the product of the two different functions f into gx, then should be equal to fx into gx. If we find the product of this function is fx is equal to this and f into gx is equal to this, or f into gx is equal to this. Similarly, if we want to find the quotient form of the function, f and g is denoted and defined as f upon gx is equal to fx or upon gx, provided gx should be not equal to 0. Similarly, we also define kfx is equal to this, where k is any scalar, or if f raised to the power n is equal to fx raised to the power n. Suppose we want to find it, fx is given this, so we want to find f cube x, so then this should be equal to fx का whole cube, or this is equal to 2x square का whole cube, or that is say 8x raised to the power 6. So this is called the algebra of the function. Now we discuss the some problem on the algebra of the real function. Yes. Now we solve the some problem on the base of the operation of the function. Let fx is equal to x square and gx is equal to 2x plus 1 are the given two real function. Then find the following function. Here we see, we observe here the domain of the function f is real number and the domain of the g function is also the real number. So then the domain of the f plus g, f minus g and f into g is always, and this is also is always equal to the common domain of the f and g. Yani कि the domain of these function should be equal to the domain of f intersection domain of g. But in case of the quotient form, we special care to find the domain of the function f upon g. The solution here, if we find the part first, then we get fx is equal to this, to f plus g by taking x is any arbitrary element, or this is equal to fx plus gx by the definition of the sum of the two functions, or fx is equal to x square, or that is say 2x plus 1. Or for second part is f minus gx is equal to fx minus gx, or this is equal to x square minus 2x or minus 1. We can also write this function is also can be written as x plus 1 का whole square. If you see the third part is f into gx is equal to fx into that is say gx, or this is equal to fx into gx, value of the fx is 2x, or into 2x, sorry, x square or into 2x plus 1, or this is equal to 2x cube or plus के x square. Now we see the part number 4th and 5th. It also part number 4th and 5th. That is f upon g or x is equal to fx upon gx. The value of fx is x square upon 2x plus 1. Or this is fifth part, f cube minus 5g, or that is x is equal to f cube x or minus 5g into x. Then by the definition f cube x को हम लिख सकते हैं बच्चों f x का होल क्यूब माइनस 5 और that is say gx, or this is equal to fx means x square whole cube और माइनस के 5 into gx, minus 5 into 2x plus 1 is equal to x raised to the power 6 minus 10x or minus 5. So therefore we evaluate the sum, product, difference and quotient form of the two functions if both functions are defined. Yes. If fx is equal to x minus 1 upon x, then prove that is this. Solution. That is, देखिए अगर हम लोग इसमें देखें fx cube is equal to x cube minus 1 upon x cube and f1 by x is equal to 1 by x or minus 1 upon 1 by x, or this is equal to 1 by x minus x. Now we find, so therefore RHS should be equal to fx cube or plus 3f 1 by x, or this is equal to fx cube, x cube minus 1 by x cube or plus 3 into this 1 by x or minus x, or this is equal to x cube minus 1 by x cube minus 3 x minus 1 by x. Or we can also write 1 by x cube minus 3x into 1 by x, x minus 1 by x. So this is equal to, or this is equal to, we say here x आपका आ जाएगा x minus 1 by x का whole cube, or this is equal to fx whole cube, fx raised to the power 3, or is equal to, that is LHS. So therefore this question is also proved. If fx is equal to x cube minus 1 upon x cube, next question. If fx is equal to x cube or plus 1 upon x cube minus 1 upon x cube, prove that हमें प्रूव करना है fx plus 1 upon x is equal to 0. Solution. Let me take here left hand side is equal to fx plus f1 by x. As the given question is fx is equal to x cube minus 1 upon x cube or plus 1 by x. We replace this x is 1 by x. So 1 by x cube minus 1 upon 1 by x cube, or this is equal to x cube minus 1 by x cube plus 1 by x cube minus, that is say x cube, or this is equal to 0, or this is equal to RHS. Now you see the next question. If fx is equal to x plus 1, if fx is equal to x plus 1, fx is equal to x plus 1 upon x, then prove that fx का whole cube, fx whole cube is equal to fx cube और प्लस 3 इंटू f1 अपॉन x. देखिए ये क्वेश्चन हमने आपका अभी प्रूव किया था, जैसे द सेम क्वेश्चन उसी तरह से आपको ये प्रूव करना है. नेक्स्ट क्वेश्चन अगर हम देखें तो दैट इज इफ y is equal to fx or this is equal to 6x minus 5 upon 5x minus 6 and prove that fy then prove that fy should be equal to x, or that is an identity function, x not equal to 6 by 5. If x is equal to 6 by 5, then the function is not defined. सॉल्यूशन अगर हम यहाँ इसका देखें तो हम लोग चाहते हैं fy, और fy मीन्स हमारे पास वैल्यू चाहिए fy and the value of fy put from here f of fx, or this is equal to fx is 6x minus 5 upon 5x minus 6. If we assume let अंदर 6x minus 5 upon 5x minus 6 is equal to t, so then f6x minus 5 upon 5x minus 6 is equal to ft, or this is equal to ft means 6t minus 5 upon 5t minus 6. So now replace the value of here t. अगर हम यहाँ पर t की वैल्यू वापस रखें तो that is say t, और ft is equal to this, so this is equal to 6 into t, 6x minus 5 upon 5x minus 6 और माइनस के that is 5 अपॉन देखा जाए तो 5x और 5 into x पे t, that is a say t, और t हमारे पास ये, तो 6x minus 5 upon 5x minus 6 or that is minus 6. Now by simplifying this function is 6 into this or 5 into this, 36 minus 30 or minus 25x minus minus plus 30 upon 30x minus 25 minus 30x plus that is 36, or this is equal to fy should be equal to, अगर हम यहाँ देखें तो 30 से आपका 30 कैंसल और that is 11x अपॉन 30x से 36 कैंसिल और 11 और that is equal to fy. So therefore fy should be equal to this.